Effects of heat. Change in temperature. When a body is heated, there is a rise in temperature of the body except during change of phase from solid to liquid or liquid to gas. Change of state of matter. On heating a solid, its temperature. On heating a solid, its temperature rises up to a definite temperature known as the melting point. If we further supply heat to the body, it starts to melt. That means it changes its state from solid to liquid without changing its temperature. Further heating the substance increases the temperature of liquid to another definite temperature known as boiling point or further boiling point, and further supply of heat to the liquid changes its state from liquid to vapor state. Electric effect. When a difference in temperature is maintained between two junctions of a pair of dissimilar metals forming a closed circuit, a potential difference is developed across the junctions which makes the electric current flow in the circuit. Change in physical properties. Heating a substance can produce change in physical properties like color, shape, and size, volume, etc. Change in chemical properties. Change in electric properties like resistance. Differences between heat and temperature. Heat is a kind of energy which produces in us the sensation of hotness and coldness. Temperature is a degree of hotness or coldness of a body. Change in heat content in a body results in change in internal energy. Change in heat content of a body may or may not result in change of temperature. Heat energy of a body is the total kinetic energy of all of its molecules. Temperature of a body is the measure of average thermal energy per molecule. Two bodies in thermal equilibrium may or same amount of heat. Two bodies in thermal equilibrium must have same temperature. Flow of heat from one body to another is independent of the amount of heat contained in them. Flow of heat between two bodies depends on their temperature. It depends on their temperature. Heat flows from a body at higher temperature to a body at lower temperature. Calorimeter is used to perform the experiments related to heat. Temperature of a body is measured by a thermometer. It is a cause temperature is its effect. Unit of heat energy is joule in SI system and calorie in CGS system. Unit of temperature is Kelvin in SI system and degree Celsius in CGS system. Okay, now we are going to study about the thermal equilibrium. Oh my god, my mobile fall down. Okay, thermal equilibrium is know that the bodies having different temperature have the molecules with different kinetic energy, so they have different tendency to provide heat energy to other body or to receive heat energy from other body. The bodies at high temperature have the molecules with greater kinetic energy, so it has greater tendency to make heat flow from it to another body. If two bodies at two different temperatures are kept in thermal contact, flow of heat starts from a body at higher temperature to another body at lower temperature, and it continues till their temperature becomes equal and the net flow of heat from one another body to one body to another body is zero. Thus, a state of equality of temperature is reached, and this state is known as thermal equilibrium state. Hence, all those bodies which are in thermal equilibrium have a physical quantity having same value, and that physical quantity is known as, what do you think, temperature. Some application of thermal equilibrium. Thermodynamics. In thermodynamics, thermal equilibrium is used to define the concept of temperature. When two systems are in thermal equilibrium with each other, they have the same temperature. This is the basis of the zeroth law of thermodynamics, which states that if two systems are in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. Mercury thermometer works on the principle of thermal equilibrium. Heat transfer. Mercury thermometer. Heat transfer. Thermal equilibrium is also important in the study of heat transfer. When two bodies are in thermal equilibrium, there is no net heat transfer between them. Material science. Thermal equilibrium is also relevant in material science as it affects the properties of materials. For example, when a metal is heated, its atoms vibrate more rapidly and the metal expands. When the metal reaches thermal equilibrium with its surroundings, the expansion stops and the material stabilized. Zeroth law of thermodynamics. Oh, I have forgotten this note. Two bodies in thermal equilibrium does not mean that both of them have same quantity of heat, but they are at same temperature. Zeroth law of thermodynamics is know that heat always tends to flow from a body at higher temperature to a body at lower temperature when they are kept in thermal contact. When a body loses heat, its temperature decreases, whereas when a body gains the heat, its temperature increases. So, two bodies in thermal contact shares the heat until they will attain the same temperature. Now the bodies are said to be in thermal equilibrium since the amount of heat in both of them now will remain constant. That means heat do not flow from one body to another. Zeroth law of thermodynamics, which states that if two systems are separately in thermal equilibrium with a third system, then they must be in thermal equilibrium with each other. To explain zeroth law of thermodynamics, let us consider three thermodynamical systems A, B, and C. In an insulated system in which A and B are separated from each other by an adiabatic wall, non-conducting wall, and a diathermic wall conducting wire separates C from A and B. If they are left as such for some time, the heat flows between A and C and between B and C until they will attain the thermal equilibrium condition. Now the systems A and C should be at same temperature. Similarly, the system B and C should be also at same temperature. That means TA is equal to TC and TB is equal to TC. So the temperature of the system A should be equal to the temperature of the system B. That means the systems A and B should also be separately in thermal equilibrium. When the insulating valve between systems A and B is replaced by a conducting valve, no heat flows take place between A and B, indicating that A and B are also in thermal equilibrium, which proves the statement of Zeroth law of thermodynamics. This also helps to define temperature as a physical quantity which indicates whether the given body are in thermal equilibrium or not with each other. A thermometer is laid out in direct sunlight. Does this temperature measure the temperature of air or sun or what? The thermometer, when laid out in direct sunlight, it will not be in thermal equilibrium with the air around it and the sun. Thus, it exchanges the heat with its surroundings and tries to be in thermal equilibrium, which makes the thermometric substance change the reading shown by it, which depends on its own temperature. So it does not measure the temperature of air in the sun. So it measures the temperature of thermometric substance used in thermometer. Thermometry, the branch of heat relating to the measure of temperature of a body, is called thermometry. The thermometry which deals with the measurement of high temperature is known as pyrometry. Thermometer is an instrument which is used to measure temperature of a body. The essential requisites of a thermometer are construction. For the construction of a thermometer, the proper choice of a substance whose certain physical property varies uniformly with temperature is essential. The substance which is used in thermometer is known as thermometric substance, and its property which is used to measure the temperature is called thermometric property. For example, change in volume of liquid in a liquid temperature is called thermometric property. For example, change in volume of liquid in a liquid thermometer. So here volume is a thermometric property of the liquid. Calibration. For calibration of a thermometer, we select two such states of a substance which can be easily obtained at any time. One is a state of melting ice at standard atmospheric pressure, and the other is the state of boiling water at standard boiling water is in corresponding temperature known as ice point and steam points are given arbitrary numerical values, and the interval between them is divided into an arbitrary number of equal parts. Each part is called a degree, which is the unit of temperature. Sensitiveness. The instrument once constructed and calibrated should also be sensitive. The thermometer will be sensitive if A. It can detect even a small change in temperature. B. It shows the temperature of body in a short time, and C. It does not take large quantity of heat for its own heating or cooling from body whose temperature is to be measured. Two thermometers are constructed in the same way except that one has a spherical bulb and other has an elongated cylindrical bulb. Which one will respond quickly to the temperature? As you know, the sensitivity of a thermometer can be increased by increasing the surface area of the bulb, which comes in contact with the body whose temperature has to be measured. Since the surface area of the cylindrical bulb is greater than that of spherical bulb, so if both of them are used at once, due to greater surface area, bulb of thermometer having cylindrical bulb absorbs heat more quickly and responds faster than the thermometer consisting of a spherical ball. Different temperature scales. The range between the two fixed temperatures is known as fundamental interval, which when divided into a number division forms a thermometric scales. There are some commonly used temperature scales. They are Celsius scale, Fahrenheit scale, Kelvin scale, Reaumur scale, Rankine scale. In each scale, first the value of some chosen thermometric property X is measured to fixed temperature. That means steam point theta s and ice point theta I. Let xs and xi be the values of x and steam and ice point respectively. Similarly, the value of chosen thermometric property, the temperature theta to be measured is x theta. The change in value of thermometric property is directly proportional to the corresponding change in temperature. So xs minus xi is directly proportional to theta s minus theta I. X theta minus xi is directly proportional to theta minus theta I. Dividing the equation, we get x theta minus xi upon xs is equals to theta minus theta I, theta upon theta s minus theta I. The above equation is used in different temperature scales. Celsius scale. In this scale, steam point is given a value 100 degree Celsius and ice point is 0 degree Celsius, and the interval between them is divided into 100 equal parts. Each part is said to be 1 degree Celsius or Celsius 1 degree Celsius. That means theta s is equals to 100 degree Celsius, theta I is equals to 0 degree Celsius, and theta s minus theta I is equals to 100 degree Celsius. For mercury glass thermometer, the thermometric property of mercury, which changes with respect to temperature, is the length L of mercury column. Thus, x theta is equal to L theta, xs is equal to Ls, xi is equal to Li. Then equation can be written as L theta minus Li upon Ls minus Li is equals to theta minus 0 upon 100 minus theta, or theta is equals to L theta minus Li upon Ls minus Li into 100. Fahrenheit scale. In this scale, steam point is taken as 212 degree Fahrenheit and ice point is 32 degree Fahrenheit, and the interval between them is divided into 180 equal parts. Each part is said to be 1 degree Fahrenheit. For mercury glass thermometer, equation can be written as L theta minus Li upon Ls minus Li is equals to theta minus 32 upon 180, or theta is equals to L theta minus Li upon Ls minus Li into 180 plus 33 is equals to 212. Kelvin scale. In this scale, steam point is given a value 373 Kelvin and ice point is 273 Kelvin, and the interval is divided into 100 equal parts. Each part is said to be 1 Kelvin. 1 Kelvin. And that means theta s is equal to 373 Kelvin, theta is equals to 273 Kelvin, theta s minus theta is equal to 100 Kelvin. Again, for a mercury glass thermometer, equation can be written as L theta minus Li upon Ls minus Li is equal to theta minus 273 upon 100, or theta is equals to L theta minus Li upon Ls minus Li into 100 plus 273. Reamer scale. In this scale, steam point is 80 degree R and ice point is 0 degree Reamer. The interval between them is divided into 80 equal parts. Each part is said to be 1 degree Reamer. That means L theta minus Li upon Ls minus Li is equals to theta minus 0 upon 80, or theta is equals to L theta minus Li upon Ls minus Li into 80. Rankine scale. In this scale, steam point is 672 degree Rankine and ice point is 492 degrees Rankine, and the interval between them is divided into 180 equal parts. Each part is said to be 1 degree Rankine. L theta minus Li upon Ls minus Li is equal to theta minus 492 upon 180, or theta is equals to L theta minus Li upon Ls minus Li into 180 plus 492. Now we're going to learn study more tomorrow. Okay, bye. Bye bye. Bye bye. Thank you for 1 million subscriber. Okay, bye.